So let's talk about exponential decay, the opposite of exponential growth. Okay, so what is exponential decay? So exponential decay happens when the value decreases over time, and we model it using exponential functions that are decreasing. So there are two main forms that represents decay. The first form is that when you have a function like this, so in this case b is greater than 1 while the k is a negative value. The k is less than 1. So here the negative value of k flips the graph, making it decreases instead of grow. The next function is same function, but in this case b is the base is in between 0 and 1. So in this case b is really already less than 1, so the function naturally decreases as x increases. So if you see any exponential function with these properties, then you are looking at an exponential decay function. So in both cases, function gets smaller and smaller over time, and it never reaches to 0, but it gets closer and closer. This is called asymptote as y equals 0. So also this is a very useful function, and we use these kinds of functions to model radioactive decay, cooling temperature, depreciation in values, medicine living in bloodstream. So there are so many applications for exponential decay. So let's try to look at an example and try to understand how exponential decay works in real world scenario. Okay, so let's talk about this example. So you can pause the video and read this example few times and try to understand the question. So here this example is all about a sales decay function. So that means this talk about how sales decreases after an advertising campaign ends. So the given function is s equals 1000 multiplied by 2 to the power negative 0.5x. So first of all, you have to identify that this is an decay function. It's because your base is greater than 1. Your base is greater than 1, but your k value is less than 0, which means it is a function of this format. So that means the given function is a decay function. So here S represents the sales in dollars and X is the number of weeks after the campaign ends. So the base 2 to the power negative 0.5x is the model that gives you the exponential decay. Okay, so the first part you have to answer is what is the level of sales when the advertising campaigns ends? So first of all, let's write our function, the exponential decay function, which is 1000 multiplied by 2 to the power negative 0.5x. Okay, so if you're looking at the level of sales when the advertising campaign ends, that means you're looking at x equals 0. So to get this value, you have to substitute 0 into this function. So 1000 multiplied by 2 to the power negative 0.5 multiplied by 0. So any number, if you multiply any number by 0, you'll get a 0. So that means in the exponent, you'll get a 0. The 1000 multiplied by 2 to the power 0. So any number to the power 0 gives you a 1. So this is 1000. So if you want, you can use your calculator to get this answer. So that means the level of sales when advertising campaign ends is $1,000. So this is the starting point before the decay begins. Moving on to the second part, what is the level of sales 1 week after the end of the campaign? Well, so here it's really easy. It's just 1 week after the campaign, which means you have to substitute x equals 1 into our function, which means you have to get s evaluated at 1. So 1000 multiplied by 2 to the power negative 0.5 multiplied by 1. Use your calculator to get this answer. So this is 2 to the power negative zero point 0.5. So if you use your calculator, you'll get your answer as 707.1. So that means the level of sales 1 week after the campaign ends approximately at $707.1. So this shows how rapidly decline the sales. So, okay, part C. According to this model, will sales ever falls to zero? So let's think about the model. So the model is 1000 multiplied by this exponential function. So this is an exponential decay function. So what do you think? Will the cells ever falls to zero? Actually, no, because the cells will never actually reach to zero. Because in exponential decay, what happens is the exponential function uh, will reach to zero as x approaches to infinity. So that means as time goes, which means when x increases, cells get closer and closer to zero, but they will never hit exactly zero. They just decay towards the zero. So you can write your answer as cells will never falls to zero. They will approach zero but never reach it. So you can confirm that if you want to sketch this function. Okay, so if you sketch this function, it will be of this shape. It's going to decrease and this starts around 1000. Yeah, here also you can confirm when x goes to very large numbers, the graph will try to approach zero, but it will never reach to zero. So this is typical feature of exponential decay models. The values decays forever, but always stays positive.